Hey guys, good morning. I've noticed that last week there were quite a few people who didn't do this task. This is really important as we move forward because if you want to get that letter saying that you don't need to place it, you need to at least get through Unit 6. For those of you who did do it, great work. I was really excited to see your guys' thought process on that, which was very intuitive and was actually pretty good. I was pretty impressed with a lot of your thoughts on that. However, there are quite a few people that are still struggling. So this example problem should help you guys figure it out. Now, I did a similar video, and I'm going to go over the first part of the last video tutorial really quickly so you guys can kind of see where we're going with that, and then I'm going to expand a little bit into the rest of the problem for you. Okay, so let's see, where is that work? Right here. So this is the example problem we did. We took our basic exponential equation, y equals b times a to the x, where b is the starting value and a is the rate of change. Okay, so in this case, I just changed the numbers a little bit, so I'm not doing the exact same problem that you guys are doing. What I did is I said, well, we're going to start with two snails, two African snails, and they are going to be released into the wild. And after 5 years, there are, let's just say 10, let's say 8,000. 5 years, there's 8,000 snails. So the population has clearly like kind of exploded. You know, like there's like we released two, and from these two snails, they made 8,000 snails in 5 years. So we need to figure out how to model this using that exponential function, y equals, b times a to the x power. All right, so we know this number, b, that's the starting value, right? So that's 2. So we have y equals 2 times a to the x. We know that after, or at year 0, so when we first released them, there were 2 snails. Okay, and that would be at year 0. So year 0, total snails. And then this is the initial snails we released. So the initial value of snails released was 2. See that? Okay. We don't know this value though. We don't know what percentage it's increasing by. So in order to do that, we're going to make a little t-chart. So x, this is years, number of years. Y, this is snails per year, or snails, total snails at the end of each year. Okay, so we know that at year 0, there were 2 snails. 1. And then the next data point we know is at 5 years, there were 800 snails. So we have to go all the way up to 5. 1, 2, 3, 4, 5. And at that point, there were 800 snails. So the only things that are changing in here is this value and this value. So if I take my initial equation, y equals 2 times a to the x power, this y input right here is just this side of this table. Now we don't know what these numbers are, right? These are all question marks, which is fine. That's okay. And these are the number of years, right, which go over here. So the very first one, which I emphasized up here, this value, when x equals 0, y equals 2. Now we know that when x equals 5, y equals 800, or 8,000. So 8,000, oh, that's 800, there you go. 8,000 equals 2 times a to the, what was that, 5th year? 1, 2, 3, 4, 5. Yep. So this is the 5th power. Now we're going to treat this part of the problem right here just like a normal algebra problem. Okay, so the idea is we want to get this a all by itself. We want to figure out what a equals. So we have to undo what's been done on this side of the equation. And whatever we do to this side of the equation, we have to do to the other side, just like our normal algebra principles. So the first thing I'm going to do is I'm going to undo this times 2. So I'm going to divide this whole thing by 2. Divide this whole thing by 2. Those cross out. I'm going to draw my train tracks in here so you guys kind of understand what's happening. Okay. And that leaves me with 4,000 equals a to the 5th power. Now, there's 2 ways that you can undo an exponent, okay? Now, remember, if this was a squared, we would simply just take the square root of both sides and then be done. But since this is to the 5th power, we can take the 5th root, and you can do that using your graphing calculator. If you have one, all you have to do is press the math button. So if you press the math button, you can go down here and you see option number 5. It's got like a little X right there above the square root, and that takes you to the 5th root. But I wouldn't do that because technology is not always the same. There's a different way to put in the 5th root for almost every different calculator using. If you're using your phone, if you're using this, if you're using your computer, if you're using a different kind of graphing calculator, if you're using Desmos, they're all different. The easiest way to do this that is always the same is by undoing or changing this exponent right here to a 1. So what I told you in last week's video was the easiest way to do that was to raise this entire side of the equation. This is called taking the power of an exponent. It's an exponential rule. I can raise this to the 1/5 power. So if I multiply this by 1/5, 5 times 1/5, that just turns it into a 1. So I have to do that to the same thing on both sides, 1/5. And now I can rewrite this, 4,000 to the 1/5 power equals, by our powers of exponents, our rules of exponents, our powers property tells us that 5 raised to the 1/5 power is the same as 5 times 1/5. And just a little side note, up to the side, so I'll put it in a little bubble. 5 times 1/5 is the same thing as 5/1 times 1/5. Now all I did is I just put a 1 over this. Remember, if I just put a 1 underneath any whole number, it doesn't change that whole number at all. Like, because what's 5 divided by 1? It's just 5, right? So I can do this legally. I can turn this whole number into a fraction like this. And multiplying fractions straight across, or multiplying fractions, I just multiply straight across. So I go 5 times 1, which equals 5, and 1 times 5, which equals 5. And 5 divided by 5, that just equals 1. Okay, so by doing this, I now change this exponent up here to a 1. So 4,000 to the 1/5 power, sorry, that's 1/5, equals a to the first power. Now anything to the, anything to the first power is just itself. So I don't even need this exponent anymore. So this is actually what a equals. And I'm going to show you how to put that into your calculator. All you do is you type in 4,000, and then when you do your exponent, put your exponent in parentheses. So I'm going to show you how to do it on the graphing calculator, and then I'm going to show you how to do it on your calculator on your phone, because it's really simple. So I'm going to take 4,000, and then I'm going to push this, I'm going to push this caret button. It takes me to my exponents right there, and then I'm going to do open parentheses 1 divided by 5. Okay, if I do that, it'll give me the 5th root. It'll take me, like, instead of the square root, it'll be like the 5th root of this. So, or 4,000 to the 1/5 power. Okay, so I press enter. That gives me 5.25 approximately. So that means a equals approximately, because I rounded it off, 5.25. All right, so let's go ahead and do that on your phone calculator here. Let me see. All right, so screen lock is off. Where's the power button on this sucker? Right there, I think that's it. Yeah. So 4,000 to the, I'm gonna go open parentheses, 1 divided by 5, close parentheses, equals, hey, there it is. Okay, so let's review that one more time. I'm gonna do 4,000, and then this little button right here, X to the Y, you see that right there? X to the Y on your phone calculator. If you push that, that means I'm now, that's like the same thing as pushing the caret, you know, this little caret thing right there. You guys see it? That weird caret thing. So now all I have to do is with my 1/5. So open parentheses, 1 divided by 5, close parentheses. Now if I just press equals, this should give me my answer. And it does. So 5.253%. All right. Now what does this mean? So we now have a full equation for our snails. So it's y equals 2 because we started with 2 snails. And then they're increasing at a rate of 5.25 every year. Now, how many more snails are there going to be after 1 year? Well, there's going to be 5.25. We're going to multiply this by 5.25 because after the first year, I just put a 1 right here, and it'd be like a little more than 10 snails, right? So that means there's 5 times as many snails after 1 year. So what percentage is it increasing? If I say there's 5 times more, what percentage increase is that? Well, it's really easy to turn this into a percentage. Remember, all you do is you take this decimal right here. So how to make a decimal into a percent. And it's really easy. I just take my 5.25 and I move this decimal over 2 places. So that equals 525%. So it's increasing by 525%. That is crazy exponential growth. That is why in only 5 years, 2 snails turned into 8,000. So if I want to figure out how many this is per month, all I do is I take this right here and I divide it by 12 because there's 12 months in a year. So for instance, let's say I wanted to know what happened after 1 month in the first year. So I would be like, that number would be y equals 2 times 5.25. So if I release them in January 1st, so like the very first of the year, how many snails would there be at the end of that month? So it would be this times 1/12, because that'd be 1 month. If I wanted to see how many there were going to be in March, so January, February, March, so that's the 3rd month of the year, I would say after 3 months, so 3 divided by 12, so that's how I do it. Let's say I wanted to know how many there would be after, let's say, in March of the 2nd year. So 1 whole year has gone by, and the next March, I want to see how many snails are going to be. Well, I have to leave this bottom number as 12, and I say, how many months have there been up to this point? Well, if that case, there'd be 12 months plus 3 more, so that'd be 15 months total. So that's what my exponent would look like. Okay, so that's how I do my monthly growth. Okay, so hopefully this helps you guys get through these next few parts of this this task. If you're still having problems, let me know. Email me. I'm going to upload this video, and hopefully that will help you guys out from there. Okay, so look forward to talking to you soon. This is all there's going to be this month or this week is just this problem. I'm going to introduce more problems that are similar and a little bit harder next week. But I want to make sure that we have this down first. So make sure you get any past work in and get this down to a T by the end of this week. Okay. Thanks, guys. I'll talk to you soon. Bye. And I'll see you tomorrow at the cap and gown thing. I'm going to be there. I'll be the last shift, so from 12:30 to the end. Okay. Bye, guys.